Hello and welcome to All Sides Academy. In this episode, we're going to look at integers, powers, and roots, and it's the foundation stage. This worksheet is available in PDF form. You can be able to download a free copy using the link in the description down below. So we're going to start with types of numbers. I recommend that you pause this video and get to go through the things to remember. So question 1 talks about the square of a number. A square is multiplying the number by itself, and when we multiply that, we get 64. The cube of a number is multiplying the number by itself 3 times. So when we multiply 10 3 times, it gives you 1,000. Estimating the value of a square root. So in this case, you're going to consider perfect squares. Squares are numbers that you multiply by itself. So 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, and 6 squared. Then you need to identify where the 20 lies. It lies between which perfect squares? In this case, it lies between 16 and 25. So we're going to write that down. So of course, if the 20 lies between 16 and 25, we're going to write this as 20 is between 16 and 25. And because it's between 16 and 25, it also means that its square root has to also be between the square root of 16 and the square root of 25. Now, the square root of 20 is between, the square root of 16 is 4, the square root of 25 is 5. Here is a list of 8 numbers. From the list, write down a factor of 20. Factors are numbers you multiply together to get 20. So 1 times 20 is normally the obvious pair of factors. So those are the factors, and the ones that are in the list are 4 and 5. So any of the two will give you a mark. So you can either write 4 or 5. Yeah, 1 is totally okay. A multiple of 10. What are multiples? Now you have to think of the times table, the 10 times table. 10 times 1 is 10, 10 times 2 is 20, 10 times 20, that's 20. 10 times 3 will give you 30. I'm going to max, yes, so 10 times 4 gives you 40. I'll use lines right there so that I'm able to separate my work very neatly. So the numbers that are available in the list we are given are 30 and 40. So you can write any of the two options. The next question asks us to write a prime number that's greater than 15. So we'll consider the numbers greater than 15. Now, a prime number has only 2 factors. So we want to list all the factors of these numbers that are greater than 15 and then consider the one that has only 2 factors, 1 and itself. So I have listed the factors of 25. The factors of 29 are 1 and 29. The factors of 30 will be numbers you multiply together to get 30. So 1 and 30 is one of the factors. Then we go to 2 and 15, then 3 and 10, then 5 and 6. And then we go to the next number, which is 33. The factors of 33, the numbers you multiply together to get 33. So the first pair will be 1 and 33. The second one will be 3 and 11. And then the next number is 39. So 39 will be given by 1 times 39. Then we also have 3 times 13. And then the last one, which is 40, a neat line, of course, right there. 40 gives us 1 times 40. Then we also have 2 times 20. And then we have 4 times, not 5, 4 times 10, and then any other 5 times 8. So all those are factors. So the only number that has 2 factors is 29. All right, so this one asks us to express 180 as a product of its prime factors. So here I'm going to use a factor tree. This is what I mean by a factor tree. So I write 180 and then I write two neat terms right there. So I start with the first prime number, which is a 2. So it's 2 times 90. And then I go to the next one. I figure out whether there's still a prime number that can go to 90, and then of course 90 is an even number, so 2 goes into 90 45 times. I go to the next prime number that can go to 45, so in this case I'll go to 3. So 3 times 15 gives me 45. 3 can still go into 15, so I'm going to write that down as 3 and 5. So having exhausted all those numbers, I'm going to list them down. So listing them down, it will be 2 times 2 times 3 times 3 times 5. And that way I have listed 180 as a product of its factors. So here, write down the value of 7 squared. So 7 squared is 49. Write down the value of the square root of 25. Now, 25 is the same as 5 times 5, so the square root will be 5. Write down, yes, so 5 times 5, so the square root is 5 right there. Write down the value of 2 cubed. 2 cubed is multiplying 2 by itself 3 times. 2 times 2 times 2, and that gives you 8. Write down the value of the square root of 81. All right, so 81 can be written as 9 times 9. So here I was supposed to write 9. So the square root of 81 is 9. 5 squared is 5 times 5, which is 25. 2 cubed is 2 times 2 times 2, which is 8. So here we are adding the 2. So 25 plus 8 should give you 33. And that's your solution. All right, so here is a list of numbers. We need odd numbers. Odd numbers are numbers that do not end with 2, 4, 6, 8, and 10, yeah, and 0. So we're basically saying numbers that are not even numbers, yeah. So here in the list we have 3 and we have 15. A multiple of 6, so 3 or 15. So remember, it's a list, an odd number, so it's only one. A multiple of 6, we think about the 6 times table. So we have 6, 12. So I'll continue up until I'm almost above 24, the highest number right there. So 6 times 3 will give you 18. 6 times 4 will give you what, guys? 18, and then right there we have 24. All right, there's no need to continue. So we have two multiples of 6, 12 or 24. Any of those should give you the answer. A factor of 18, numbers that you multiply together to get 18. So the first obvious one is 1 times 18, then the others are those, and the ones in the list are 2 or 3. All right, so here's a list of numbers. Write down an odd number. So basically write a number that is not an even number. An even number ends with 2, 4, 6, 8, and 0. So the ones that do not end with those numbers are odd numbers, yeah? So it does not end with 0, 2, 4, 6, and 8. So the numbers that don't end with that are 3, we have 5, and then we also have 21. So any of those should give you a mark. Write down the square number. Now, when you think about a square number, it's a number that you multiply by itself, yeah? It's the result of another number being multiplied by itself. So square numbers are 1 times 1, which is 1, 2 times 2, 4, 3 times 3, 9, 4 times 4, 16. So that's what's happening there. Write down the number which is a multiple of 6. Again, the 6 times table. So we have 6, 12, 18, and then we also have 24. So the ones that are in the list are, we have the ones that are in the list are 24, just 24. Yeah, so here's a list of numbers. We want 3 different prime numbers that when we add together, we will have a result of 20. So you have to list the prime numbers first. Remember, 2 is the smallest even prime number, and it's actually the only even prime number. So we try and add those numbers to see the ones that give us 20. So 2, 7, and 11 give us 20. I want you to pause this video and check for another pair. So we have another one, which is 2, 5, and 13. Question is asking you to find what time both bells will ring together next. So we're going to consider the multiples of 9 and 12. And the multiples of 9 and 12, starting with the multiples of 9, 9, 18, 27, 36, and 45. And then we go to the multiples of 12, which are 12, 24, 36, 48. So we are going to look for multiples that are common. So basically, this will tell you the common time that these two alarms will go off at the same time. So there we have 36 as the first time. So it will go off after 36 minutes, right? So that will write after 36 minutes. So from the time that they both sounded together, 6:45, we're going to add the 36 minutes to 6:45. And when we do that, we will add the minutes together. So I'm going to add that as 81 on the side of minutes, and then of course we have 6 on the side of hours. And then remember, we need to change the 81 minutes to an hour and some minutes, because the maximum number of minutes we have in an hour is 60. So we're going to subtract 81 and 60. So 81 take away 60 gives you 21 minutes. And remember, the 60 minutes we've taken is an hour. Yeah, so we're going to add 1 hour to 6, and that gives us 7:21 a.m. The next question asks us about table decorations. So in this question, we are going to consider the number of candles in each pack and the number of holders in each pack. So we are asked to actually write how many packs of candles and how many packs of holders Caroline needs to buy for them to be the same, exactly the same. So in this case, we'll consider multiples of 30 and 18. So the multiples of 30 and 18, I'll start with multiples of 30, 30, 60, 90, 120, and then I go to the multiples of 18, 18, 36, 54, 72, 90, and then we continue and so on. So already I have a common multiple that tells you that after buying a couple of 3 packs of candles and 5 packs of holders, the number of candles and holders will be the same. So in our answer, we will write, we will need 3 packs of candles and 5 packs of holders. So that's what we are required there. In this second question, they are asking us how many decorations that we need in this case. So of course we have to write down the number of candles that we have and the number of holders that we have, and then consider what makes the decorations. So in this case, we are told that each decoration is made from a candle holder, a candle and a holder. So we need 1 candle and 1 holder for each. So if we have those, then there'll be 90 decorations in that case. This question gives us 2 buses. One goes to the bus station after every 24 minutes, and then the other one leaves the same bus station every 20 minutes. So we are told that a bus to Acton and a bus to Burton both leave the bus station at 9 a.m. And what we are asked is, what time, when will a bus to Acton and a bus to Burton next leave the bus at station at the same time? So in this case, we are still going to consider the multiples of 24 and the multiples of 20. So multiples of 24, multiples of 24 and multiples of 20. So multiples of 24 are 24, 48, 72, 96, 120, and so on. And then multiples of 20 are 20, 40, 60, 80, 100, 120. All right, there we already have a common multiple for the two. So we're going to identify that. So that means they will be able to leave the next bus station at the same time after 120 minutes. Okay, so we change the minutes to hours. Those are 2 hours, and then we add the hours to the time that they both left the bus station. So when we add 9 a.m. and 2 hours, it will give us 11 a.m. Or you can go a longer way of adding them by saying that's 900 and 200, and that still gives you the very same answer, 11 a.m. So the next question is giving us a question about Rita going to some cheeseburgers for a party, going to make some cheeseburgers for a party. So she buys some packets of cheese slices and some boxes of burgers. There are 20 cheese slices in each packet. There are 12 burgers in each box. So Rita buys exactly the same number of cheese slices and burgers. How many packets of cheese slices and how many boxes of burgers does she buy? So in this case, we will consider the multiples of 20 and the multiples of 12, because if she's buying them in packets, remember multiples increase, in 20s or in 12s. That's why we are considering the multiples. And then the multiples of 12 right there are 36 and 48 and 60 and 72. So already we have multiples that are appearing to be the same. So we consider the number of packets. So for the cheese slices, we will have 3 packets, which gives us 60 of them. And for the burgers, we'll have 5 packets, which will give us 60 of them. Yeah. So 3 packets of cheese slices and 5 packets of burgers. So this one asks us to find how many bread rolls Rita will make. So we need to identify how many cheese slices we have and how many burgers. And then we go to the description of how to make a bread roll. So 1 cheese slice and 1 burger. So if we have 60 of each, then we'll have 60 bread rolls out of all those 2. So that gives us 60 bread rolls. In this question, we are given Vina bought some food for a barbecue. She is going to make some hot dogs. Oh, who doesn't love hot dogs? She needs a bread roll and a sausage for each hot dog. There are 40 bread rolls in a packet. In a pack, there are 24 sausages in a pack. So Vina bought exactly the same number of bread rolls and sausages, the same number. So this already gives you the hint of multiples. So we're going to write down multiples of 40 and multiples of 24. So multiples of 40 will be given by 40, 80, 120, 160, 200, and so on. 24, 48, 72, 96, 120, and so on. Already I've identified 2 of them that are the same. Yeah, so that gives me 3 packs of bread rolls and 5 packs of sausages. And then in the second question, it asks how many hot dogs can she make? So ensure you know the number of each that she has. So that's 120 bread rolls and 120 sausages, and she needs one from each. So if we have 120 each, we'll need 120 hot dogs in that case, so 120. The next question asks us to find the highest common factor of 32, 48, and 72. So I'll list down the factors of each. The first factor that is always obvious is the number and 1 and itself, yeah? And then we have 4 times 8, and then for 48, we have 1 times 48, 2 times 24, 24, 2 times 24, right there. And then we have 3 times 16, 4 times 12. And then we have 6 times 8. In 72, we'll have 1 times 72. And then we'll also have 2 times 36. And then we have 3 times 24. And then we have 4 times 18. And then, of course, we have 6 times 12. And then finally, 8 times 9. All right, so we now need to list down all those factors. So 3 will have 1, 2, 4, 8, 16, 8, 16, and 32. And then 48 will have 1, 2, 3, 4, 6, 8, 12, 16, 24, and 48. Again, I mean, putting them in this order will help you be able to identify the ones that are common, because first we have listed the factors. We need the ones that are common, and then out of the common ones, we identify the highest. That's why I'm putting all of them in this order. So once I have the 18, 24, 36, and 72 listed, I identify the common ones. So it's easy to see. So we have ones, they are common, twos, and then we have 4, and then finally we have the 8 as the last common one. The highest in this case is 8. So I'll circle that for all the numbers. So the highest common factor of these numbers will be 8. Yeah, so it's so easy. I'll write that as the HCF is equal to 8. Write 504 as a product of powers of its prime numbers. So I'll use a factor tree to list out all the prime factors of 504. The next one is 2 still, because this is an even number. 2 goes into 126 63 times. I go to 3 as the next one. So 3 goes into 62. How many times? 21 times. Then 3 can still divide 21 7 times. So 3 and 7. So once I've done that, I'll list down all those prime factors. So 504 is equal to 2 times 2 times 2 times 3 times 3 times 7. Now the question asks you to express it as a product of powers. So I'm going to put all those numbers together in power form and then write them as a product as such. Yeah, so 2 to power 3 times 3 to power 2 times 7. Okay, this question asks us, or rather tells us that John buys some boxes of pencils and some boxes of pens for people to use at a conference. There are 40 pencils in a box. There are 15 pens in a packet. John gives 1 pencil and 1 pen to each person at the conference. He has no pencils left. He has no pens left. How many boxes of pencils and how many packets of pens did John buy? So this already gives you the hint of considering multiples and then us identifying which of the multiples is common. Yeah, so we are going to list down the multiples of 40 and 15 in this case. So multiples of 40 and 15. The multiples of 40 will be 40, 80, 120, 160, 200, and so on. And the multiples of 15 will be 15, 30, 45, 60, 75, 90, 105, 120. Already I have a factor that is common to the two, a multiple that is common to the two. So we have 120 and 120. So that means there are 120 pencils and 120 pens. So that makes a pack of 3 for the pencils and a pack of 8 for the pens. So we will have 3 boxes of pencils and 8 packets of pens. So 3 and 8 right there. Now, here we are having loads of indices. So we're going to break them down in this box so that you can be able to remember them. Loads of indices. So in an exam, they will always use the word simplify. When multiplying, add the indices. So indices are powers. So m and n are the powers. So if I'm multiplying two numbers that have the same bases, the a's, then I'll add the indices or add the powers. If I'm dividing the numbers, I will subtract the indices. So n minus m. The next one is with brackets, multiply the indices. So if I have a to power n and to power m, I multiply n and m. Anything to the power of 0 is 1. Any number, 1 million to power 0 is 1. 10 million to power 0 is 1. 2 to power 0 is 1. Anything to the power 1 is itself. And then the last one, any number to a negative power becomes a reciprocal. Okay, so whether it's a to power negative 1 or a to power negative n, that's a reciprocal. Write down the reciprocal of 5. Okay, so here we start with the reciprocal. 5 as a reciprocal, if we write it in power form, we're going to write it as, so 5 as a normal number is 5 over 1. So the reciprocal means we want to interchange the numerator and the denominator. Yeah, so that becomes 1 over 5. Evaluate 3 to power negative 2. The negative is always giving you a reciprocal. So that is 1 over 3 squared. 3 squared is 3 times 3, which is 9. So 1 over 9 is our answer for that question, 1 over 9. Now write down the value of the square root of 81. So the square root of 81 can be written as the square root of 9 times 9. Now the square root of 9 times 9 is 9. Work out the value of that. 5 squared is 5 times 5, which is 25. 2 cubed is 2 times 2 times 2, which is 8. So we are adding the two numbers, 25 plus 8, which gives us 32. Write these numbers in 33, sorry. Write these numbers in order of size. Start with the smallest. So I'm going to try and write those numbers in a better way so that I'm able to compare them. And then use a number line to see which of them is the smallest and which one is the largest. So I'm going to write a number line right there. Put the negatives on my left-hand side. Put the positives on the right-hand side, the negatives on the left-hand side, and then, of course, identify which of them is the smallest. So I have the number line right there. I have my 0 as the center. So I'll start with the negatives, and we have only one, -5. And then the positives, the smallest will be 0.2, then 0.5, then finally 1. So here I'm going to just list them in the original form that they came with. So -5, and then we have 0.2, which is 5 to power -1. And then we have 0.5, which just appears as 0.5 in the question. So 0, write that, 0.5, and then finally 1, which is 5 to the power of 0. Remember, 5 to the power of 0 is 1. Solve 3x squared equals to 147. So here we want to eliminate the 3 by dividing it to both sides. So we'll remain with 349. So I'll make a line right there and then say x squared is equal to 49. So x is finding the square root of 49, and that gives me, now remember 49, when you're writing 49, I want to point this out. When we are writing 49, remember when we are multiplying positive numbers and negative numbers together. So 49 can be found by 7 times 7. It can also be found by 2 negative 7s. Yeah, so the square root of x then can either be positive 7 or negative 7. Work out the value of 2 to the power of -3. Negative gives us a reciprocal. Remember that. So that's 1 over 2 times 2 times 2, which is 1 over 8. And that's our answer. Simplify 1 over 8. Simplify 3x squared to the power of 3. So we are basically multiplying the 3x squared 3 times. So 3x squared times 3x squared times 3x squared. So I want to work with the numbers 3 times 3 times 3, which gives me 27. That's a 7. And then the letters. Now here I'll bring in the law of indices. Yeah, I'll add the powers because I'm multiplying numbers with the same basis. So that's 27x to power 6. Simplify. The first law of indices tells us that we can add the powers or add the indices if we are multiplying the numbers. So 4 plus 5 gives you 9. So a to power 9. A to power 9, you have to remember that. Here, simplify. So I'm going to divide the numbers together, the letters together, each letter with the other, yeah? So 45 divided by 5 is 9. E to power 6 divide by e to power, so e is just e to power 1. Dividing numbers, I can subtract the powers, and then f to the power of 8 divided by f to the power of 2. That gives me f to power 8 minus 2, which is f to power 6. So rewriting the answer will be 9 e to power 5 f to power 6. Write down the value of 9 to the power of half. So when we bring in fractions as indices, they're basically giving us roots. So a to power half is the square root. A to power a third is the cube root. So that means that a to power 1 over n, I'll write that as a to power 1 over n is going to be given us the nth root of a. Right, I need to separate the n and the roots right there. So n and a, yes, the nth root. So 9 to power half is the square root of 9. And we know the square root of 9, or rather 9 can be written as 3 times 3. So the square root of 9 is 3. Simplify. These are numbers that are being multiplied, so we can add the powers. So that gives us 5 to power 10. Here they are being divided, we subtract the powers. 5 minus 2 is 3, so 7 to power 3. Write down the value of 7 to the power of 0. Okay, I'm gonna write these others down first in the answers. 7 to power 3, 5 to power 10. All right, 7 to power 0 is, any number to the power of 0 is 1. 5 to power -1, that's a reciprocal. 9 to power half, the square root of 9, which is the square root of 9. All right, so let me write that. Square root of 9, which is 3 times 3, and the square root of 9 is 3. Work out 3 to power 4. 3 to power 4 is multiplying 3 by itself 4 times. So that's 9 and 9, and 9 times 9 gives you 81 right there. Write down the cube root of 64. So in this case, cube root can be written as a fraction, a power fraction. Now, cube root is basically what 3 numbers do you multiply by itself? What number do you multiply by itself 3 times to get 64? So you can always start with 1 times 1 times 1, 2 times 2 times 2, 3 times 3 times 3. Another way is to express 64 as 4 to the power of 3, and then introduce the law of the brackets. When you have a power and another power outside, we are multiplying the powers, so that will still give you 4 to power 1, which is 4. Yeah.